Good morning, students. I am Santan, working as a physics faculty in Target English Medium School. Today, in the chapter of motion, in this part 2 video, I would like to teach what is acceleration, which type of acceleration we are called constant acceleration, and how many kinematic equations are there, or how many equations of accelerated motion of a body is there, and how we can prove the 4 kinematic equations. And finally, so how to find acceleration and velocity with help of an inclined plane track. So this type of topics mostly I try to cover in this part video, in the chapter of motion. Now let me come to our topic directly. What is our topic? Means acceleration. Acceleration is nothing but simply we can write the rate of change of velocity, the rate of change of velocity of a body is called acceleration. So listen very carefully. Rate of change means so the change in the velocity with respect to the time, that is the meaning of rate of change. The rate of change of velocity of a body is called acceleration. So A is equals to delta V by delta T. So V is change in the velocity, T is change in the velocity. Delta symbol is always represented the change. Here V means velocity. That's why change in velocity with respect to the time. For understanding of you, let us consider a body of mass is m. So listen very carefully. Let us consider a body of mass is m. That body is initially move with u velocity. U is nothing but initial velocity of the body. Now, on that body we are applied some external force up to the t time. Listen very carefully. So when a body is moving with u velocity, the time t is equals to 0 second. Just you can consider that. Why? Because here we are not applying the force still. When you apply the force, we are consider that time. Or one more thing, if a body, let us consider a body of mass is m. Initially, it is in the rest position. So like that one is also I consider. T is equals to 0 second. So u is equals to 0, means initial velocity of a body is 0. Now on this body we are applied F external force up to t time, then the body is t1. Move from their initial position to another position. After apply the force on the body, what we are observing that the body set into the motion. Initially body is in which state? Rest position. But after apply the force, the body is in motion, means it acquires certain velocity. That velocity we are called V. V is the final velocity. Means according to this one, simply we are understanding that U is the initial velocity of the body before apply the force. V is the velocity of a body after apply the force. Now so T2 is equals to T seconds. Initially 0 seconds the body is at this position. After apply the force, in the T seconds it is covered certain distance with V velocity. Now here we are observing that time is changes, velocity is also changes. The rate of change of velocity is called which one? Acceleration. Okay, means here what is the initial velocity? 0. After apply the force, what is the velocity? It has certain velocity, means velocity is changes with respect to the time. That's why, so according to this situation, the body is moved with certain acceleration. Okay, so it is also we should write A is equals to V minus U by T also. Okay, so V minus U means final velocity minus initial velocity by time. So T1 is 0, means automatically T only is there. Okay, so in certain test books you can write either A equals to delta V by delta T or V minus U by T. So any one formula that is okay suitable for which one? Acceleration. What is meant by acceleration? The rate of change of velocity of a body is called acceleration. What is the formula of acceleration? A is equals to delta V by delta T or A is equals to V minus U by T. So either this one or this one we are used for the acceleration. Acceleration is a which type of quantity? Means okay, acceleration is a vector quantity. It is important. Acceleration is a vector quantity. How we can say that acceleration is nothing but change in velocity with respect to the time. Velocity is a vector. That's why our acceleration is also a vector. Because of acceleration is depend upon the velocity. That's why velocity is a vector quantity. Is nothing but it has both magnitude and as well as the direction. Now, okay, we discuss that. What are the units of acceleration? In SI and CGS units. Units of acceleration. Units of acceleration. So SI unit is so what is the formula of acceleration? We know that A is equals to V by T. Because of okay, in the previous example U is 0. If U is not 0, we are consider that. Or simply certain cases you can write V by T, velocity by time. That is the meaning of that. That's why velocity means okay, by time the units are meter per second square or okay, meter second power minus 1, sorry, minus 2. Means second square brings to the numerator side, it becomes to the minus 2. Okay. So how it is meter per second square means it become. So A is equals to velocity. Velocity is nothing but displacement by time. Okay. That's why displacement by time means here no value means is nothing but 1. It brings to the numerator side. Then what will be happen? A is equals to d by t into 1 by t is nothing but d by t square. That's why acceleration is equals to what you can write d by t square. Okay, listen very carefully. Acceleration you should be write also d by t square, displacement by time square. That is the meaning of that one. Okay, now here, so let me come to that one. What is the SI unit of displacement? Meter. What is the SI unit of time? Second. But here square is there. That's why meter per second square is the SI unit. SI means system of international. This second square brings to the numerator side meter second power minus 2. And the second one is CGS unit is according to the CGS system, the displacement is measured in centimeter. Time is in every system of unit second only. That's why second square. Or it is we should write centimeter second power minus 2. So the SI unit of acceleration is meter per second square and CGS unit is centimeter per second square. These are the units of acceleration. Now we discussed one kind of acceleration that is important for us, okay, in 9th standard level in regular subject. So already in the previous videos I am clearly explained what is the speed and what are the kinds of speed. And in the previous video also I explained what is the velocity and what is the kinds, sorry, how many kinds of velocities, like the same way. So types of accelerations or kinds of accelerations are there: uniform acceleration, variable acceleration, like. But among these, for your 9th standard level, mostly one question they are regularly asking for 1 mark or 2 marks. What is that one means? What do you mean by constant acceleration? Constant means I say that one thing, just same concept we observe in the case of uniform speed. When a body is moved with uniform speed, if a body is moved with a constant speed, at that time we say that the body is in uniform speed or uniform motion. Like the same way here, what is our concept? What do you mean by constant acceleration? Means the change in the velocity is constant. That is the meaning of that. That's why the constant acceleration we should be also write as uniform acceleration. Uniform means same, that is also constant. Uniform acceleration or constant acceleration. If a body equal changes in velocity in equal intervals of time. Listen very carefully. So when a body moves with equal changes in velocity in equal intervals of time, however the small intervals may be, then the body is in uniform acceleration. Listen very carefully once again. So if a body moving with equal changes in velocity, because of acceleration is nothing but rate of change of velocity. So once again listen very carefully, it is important. So if a body moving with equal changes in velocity in equal intervals of time, then we say that the body is moved with uniform acceleration or constant acceleration. Is nothing but the change in velocity is equal in equal intervals of time. That is the meaning of that. So means here how we are understanding that concept means I said that one example. Let us consider a body of mass is m. It is placed certain height h above the ground. So initially the initial velocity is 0 because of it is in rest position at h height from the ground. Now the object will be released from your hand. So when the object is released from your hand, what we know that on the object, by acting the earth gravitational force, the body is gradually moved to downward and finally reaches to the earth. In this one, we are considered mainly 3 points or places during the journey of the object: A, B, C. A is the starting, C is the ending, B is the mid path. So our midpoint during its path. Now here at point A, the body is in which position? Rest position initially. That's why rest position means initial velocity is 0. But when you can release it, it's set into the motion by acting the which force? Gravitational force in vertically downward. That's why the body will be acquired some velocity. Okay, so just we are consider that okay, here t is equals to 0 second. Okay, so in t equals to 1 second, it is t1, t2. So in t2 1 second, the body will be covers the point B. So in this one, its velocity is v1. We are consider that or v of b. So v of a is equals to 0. V of b is okay. It has certain velocity or not? Okay. How much velocity the body will be there? 9.8 meters per second. Okay, we know that what is the acceleration due to gravity value. Okay, so at a particular place on the surface of the earth means 9.8 meter per second square. Means so in 1 second how much acceleration will be acquired when compared to initial 9.8. Means the change in velocity from starting time to next to 1 second. Okay, so how much velocity changes? 9.8. That's why we have 9.8. We are consider that. Next, okay, t3 is equals to 2 seconds. After 2 seconds, it is 19.6 meters per second. Okay, V of C. We are consider that. Now here, okay, means just for understanding of you, I will write this. So at t1 0 second, the body is initially rested. That's why its velocity is 0. After 1 second, the body reaches to the point B. At that time, it has certain velocity because of body is in motion. That's why how much velocity is there? 9.8. Okay. Next, we are after reaches to the point C. Means before touches to the ground, so V of C equals to 19.6 because of for every 1 second 9.8 meters per second, so velocity is gradually increases 9.8 into 2 19.6. That's why here we come to that part. What is the change in velocity? Vb minus Va. Is it correct or not? V is equals to Vb minus Va according to this one. It is the initial, it is the final. That's why final minus initial. 9.8 minus this one means 9.8 meter per second. That is, you know that. Okay. Next here, Vp and Vc, between the B and C. What is the change in this one? V is equals to, it is V1, it is V2. Okay. So Vc minus Vb. So V of 2 is equals to, what is the Vc? 19.6 minus 9.8. Okay. So then finally 9.8 meter per second. So means, okay. So here velocity is changes from, okay, A to B, B to C. But the change in velocity is equal or not? In the first case, what is that one? 9.8. In the second case is also 9.8. That's why the change in velocity is equal. Next here, so 0 to 1, how much time? 1. 2 to 1 to 2, how much time? 1 second. That's why what will happen? What you are observing that intervals of time is the same or not? That's why here, okay, if a body covers or if a body moves with equal changes in velocity in equal intervals of time, then we say that the body is moving with uniform acceleration or constant acceleration. So now we discuss the, okay, kinematic equations. Are equations of accelerated motion of a body. So next our topic is kinematic equations are equations of accelerated motion of a body. Kinematic is nothing but it is one of the branch in the physics. Okay, it deals with, okay, the body is in the motion or not. Okay, but not consider okay, why, what is the reason for the motion of a body? Means, so for example, initially a object is in the rest position. Now, if you are applied sufficient external force on the body, then the body is set into the motion. But in the kinematic concept, you are consider the body is in the motion or not, but not consider, okay, applying the force. Means, what is the reason why the body is in the motion? That is no need to us. That's why. But when a body is in the motion, we know that, okay, it has initial velocity, final velocity. If velocity is changes, that is called acceleration. At the same time, the body is covered certain distance in a unit time. That's why when a body is in the motion, according to these equations of accelerated motion of a body, that's why in a accelerated motion of a body, okay, so mainly which, okay, physical quantities we are considering, that initial velocity, final velocity, displacement or distance, time and acceleration. These are the main topics we are considering here. But totally, how many kinematic equations are equations of accelerated motion of a body? Means totally 4 are there. V is equals to U plus AT. S is equals to UT plus half AT square. Third one, V square minus U square is equals to 2AS. And fourth one, V S of nth. S of n is equals to U plus A into 2n minus 1, or A into n minus 1 by 2, anyone, okay, or, okay, in certain one, U plus A into n minus 1 by 2. Okay, so these 4 equations we are called kinematic equations, or equations of accelerated motion of a body. I says that initial, final, acceleration, displacement, time, all are there or not? V is the final, U is the initial, A is the acceleration, T is the time, S is the displacement covered. Okay. So V equals to U plus AT is represented the velocity of a body with respect to the time, because of in every equation acceleration is the common factor. Okay, because of our concept is accelerated motion. That's why we are not considered here. But mainly in the first equation is gives the relation between, okay, the velocity of a body with respect to the time. The second one is the displacement of a body covered with respect to the time. Next, third one is the velocity of a body with respect to the displacement. And this one is in the nth second how much distance the body will be traveled. But in 9th standard level we discuss the first 3 only. This is not, it is in the intermediate level is there in kinematic chapter we discussed it. But I will explain how we can prove S of n is equals to U plus A of n minus 1 by 1 upon 2, like this. Okay. So totally how many equations? 4 equations are there. V equals to U plus AT, S equals to UT plus half AT square. Third one, V square minus U square is equals to 2AS. And the fourth one, S of n is equals to U plus A of 2n minus 1, or U plus A of n minus 1 by 2. So now we discussed how to prove kinematic equations or equations of accelerated motion of a body. So first one, we discuss that how to prove the first one means. Let us consider a body of mass is m. Initially, the body is moving with u initial velocity. On this body, we are applied F external force up to t time. then the body is move with further velocity, that is the v. For example, to understand, if you can take a football, the football is initially, for example, roll on the ground. So if a ball is roll on the ground means initially the ball is in the motion or not after releasing from your hand on the ground. That's why, so means a football mass is m, initially it is moved with u velocity on the ground. Now, so you are moving, okay, running along with that ball, okay, just you can say you are one of the player in the football team. Just now you can kick the ball with help of your leg. When you can kick the ball, then what will be happen? During the kicking, you are applying some force or not? At the same time, our leg will be contact with the football surface up to the T10. Okay, that's why your force will be applied by your leg. Then, so the body will be moving further. Another speed or not? Means speed is increases. That means speed or velocity changes or not? That is the v. That's why initial velocity of the body is u, final velocity of the body is v. But according to this one, simply which is the initial, which is the final, how we can understand it? Okay, before apply the force, the body is moving with a certain velocity, that is called initial. After apply the force, the body is moving with another velocity, that is either increasing or decreasing, that is called final velocity. Okay, when the velocity of your body increases, the applied force is acting on the body along the direction of the body, then the velocity is increases. If the external force is acting on the body opposite to the motion, then velocity will be decreases. That's why now let me come to that point. Here, according to this diagram, okay, velocity is changes or not? Why velocity changes after apply the force, but that is not considered? I said that according to the kinematic concept, you are considered the body is in the motion or not. But why the body is in the motion? That reason we don't want. That's why. So here velocity changes. The change in velocity is called acceleration. That's why acceleration. Okay. A is equals to, what is the formula of acceleration here? Okay, v minus u by t. Simply you can write. Okay, so that's why here t is transferred to the left hand side. This is the left hand, it is the right hand side according to my position. This is the right, this is the left. But in your view, it is the right, it is the left. But in the view of me, so the t is transferred to the left hand side. What you can write? A of t is equals to v minus u. So here, this is we can write v minus u is equals to at. For understanding of it. Okay. So now this minus u transferred to the right hand side. Then v is equals to, okay, minus u is becomes to plus u. That's why u plus at. This is the first kinematic equation. So what is the first one? I said that v equals to u plus at. V is the final velocity, u is the initial velocity, a is the acceleration acquired by the body, and t is the time. Okay. So means in this time, how much time? In the time it is covered how much displacement like that one. So okay, first one, what is our first concept to prove v is equals to u plus at. This is our concept. Okay, under this concept, first you draw the diagram. After the diagram, you can write 2-3 sentences. What is that one means? What I am telling, that is you can write in the running, during writing the running notebook. Let us consider a body of mass is m. Initially, the body is moving with u initial velocity. Okay. On the body, if external force is applied up to the t time, okay, then the body is moved with another velocity, that is the v. Here, so the velocity of a body is changes. That's why we say that the body is moved with acceleration, acceleratedly. Okay, that's why. So we know that acceleration is equals to v minus u by t. Then at equals to v minus u. Then v equals to u plus at. This is the proof of the first kinematic equation. Next, second one. To prove is equals to ut plus half at square. It is the second kinematic equation. Okay, so from the previous diagram, okay, so how many velocities we are considered? Two velocities. One is the u, another one is the v. That's why, so you can come to that one. Okay, so according to the our concept, if the body is moved with average velocity, because of when we are considered average velocity, when a body is moving with variable velocity, we are considered the average velocity from entire journey, from starting to ending. That's why here is also in the previous concept in the diagram. So initial velocity is u, final velocity is v. That's why the body is not moved with the same velocity, it is moved with variable velocity. Due to that, you can easily consider what is that one, average velocity. The average velocity of a body from the diagram, okay, is what you can write that is equals to v plus u by 2. Average means how many velocities are considered here? Two velocities. One is the u, another one is the v. That's why the average velocity of the two velocities is v plus u by 2. That is one is there. At the same way, after apply the force, we know that. Okay, so initially body is moved with u velocity. After apply the s force, it will be moved with fastly and covered certain distance in a unit time or not. Okay, that's why. Okay, what we can write the distance. Okay, so simply we can write that. Average velocity is equals to v plus u by 2. Okay, next one is the average velocity is equals to v plus u by 2. That is equals to s by t. Why we can write s by t? Okay, before this one here we are mentioning that. What is the formula of average velocity? The total displacement or the distance traveled by a body in a particular direction upon total time taken. That's why, after apply the force, the body from A point to up to B point, it is covered certain distance in one particular direction in a unit time t. That's why S by t. Here listen very carefully. Here it is the initial point is A. Velocity is u. After apply the force, v covered the b. Are understanding or not? So initially at point A, the body is mass is move with u velocity. After apply the force, that is leave it. The body will be moved with v velocity and finally reaches to the point B. Okay. Before its velocity becomes to 0. In this one, it is covered s distance in a particular time. That's why, average velocity means you know that the total time, the total distance or the total displacement traveled by a body in a total time. The total distance in a particular direction, in a straight line path, magnitude of distance and displacement both are equal. I said very clearly. That's why S by T. So, but we know that average velocity from the previous this diagram, what is the value? V plus U by 2. That's why, so average velocity means you know that V plus U by 2 is equals to S by T. We can write or not? Okay, so this is it, we can write easily here. So after this one, we are observing that, so this T is transferred to this side. Are understanding or not? Because of y means you find which value, what is our answer? S is equals to ut plus half at square, means how much distance the body will be covered from A to B. That is mean. That's why T is transferred to the which side? Left hand side. Then you can write S is equals to V plus U by 2 into T. That is one is there. So T is comes to this side. Into T. That is we know that. Now here, so we know that V is equals to U plus AT. Okay, means according to the first kinematic equation, v equals to u plus at. We know that or not? So that's why in the place of v, we substitute this value here. Then what you can write? S is equals to v means what is that one? U plus at. U plus at plus what is there? Here u. Or in the place of v, what you can write? U plus at. Then again here what is there? U upon 2 into t. Now let me come. S is equals to, okay. So now here u plus u, what is that one? 2u. 2u. And these two are multiplied with the t. Or maybe slowly you can go. 2u plus what is the remaining term inside the bracket? 18 upon 2 into t. S is equals to, okay. Here we can write separately first inside. 2u by 2 plus 18 by 2 into t. 2 get cancelled. S is equals to u into t, ut. That's why ut plus here 8t into t, t square. That's why here what is there? 80 by 2 means we can write half at means half 1 into 80. That's why 80 by 2 we can write half 80, but 3 into t square. That's why t square. So we are proving S equals ut plus half 80 square or not? That's why listen very carefully. So from the diagram, what is the average velocity? Because of in the diagram we are considered only two velocities. One is the initial, another one is the final. That's why the average velocity according to the diagram is v plus u by t. But according to the definition of the average velocity, the total distance traveled by a body in a unit in a specified direction upon total time taken. That's why average velocity is equals to s by t. Then v plus u by 2 into s by t. Then t is transferred to the left hand side. Then finally you can write s is equals to v plus u by 2 into t. Okay, so but we know that in this is where it's as a second equation. In the second equation, we substitute the equation 1 because of v equals u plus at, where it's as a equation 1. Okay, but we know that v equals u plus at. This v value substitute in the above formula in the place of v. Then s equals u plus 80 means in the place of v we can write u plus 80 plus what is there here? U upon 2 into t. U plus u, 2u plus 80 upon 2 into t. Then okay, now inside the bracket we can write separately. Means every term is divided with 2 separately. 2u by 2 plus 80 by 2 into t. T get cancelled. 2 get cancelled. U into t, ut plus 80 by 2 we can write half 80. Half 80 means 1 into 80 by 2. But here t into t is there, that's why t square. So this is the way of method to prove s is equals to ut plus half a t square. So remaining the two, okay, proof. That is I will explain in the next video. That is v square minus u square is equals to 2as, and s of n is equals to u plus a into 2n minus 1, or s of n is equals to u plus a into n minus 1 by 2. Okay, these two equations of motion I will be prove in the next video, or I will explain in the next video how we can prove. Okay, so dear students, listen very carefully. Okay, most of the cases our chapter will be comes to the ending. That's why. So if a student carefully watch the videos in the YouTube from the starting part 1 to up to still now in the chapter of motion, and also if you carefully watch the videos 3 or 4 times because of it is the offline video. That's why every student can easily understand after 3 or 4 times after carefully watch the video. Then after that we start to write the running notes. Okay, already you know that how to write the running notes in the 8th standard level, so you know very well in our subject. That's why you can write like that way. After completion, after reopen the school, I must be check every student running notebook thoroughly. Okay, if you didn't show the running notebook to me, okay, or if your running notebook is incomplete, okay, you know that what will be happen. Okay, so you know about me very well. That's why these words are keep in your mind carefully, and okay, so you will be watch the videos carefully, and okay, so write the running notebook. Thank you.